Now, after you understand this basic idea and this construction, usually they will ask you to find this width. Then what next? They will ask you about resolving power. In terms of resolving power, you need to look back at this thing. You need to look at the resolving power of a single slit. So what is resolving power? Resolving power is the ability of instrument to differentiate clearly between the images of two close objects. So imagine you have two close objects here. Let's say this is the blue object. They will generate blue interference pattern. They'll generate this. They generate this blue interference pattern. Then there's a red object. They pass through here. They generate this red interference pattern. These two interference images, the land of our retina, are they resolved? Yes, we can see them as two different images because their interference are very far apart. They do not overlap. But if you make this S1 and S2 closer like this, you see they're so close, right? You see the images start to overlap. The images, these two patterns start to overlap, right? So we do not see them as two different objects anymore. Just like that, you see? We see them as two different objects because the fringes, the interference images do not overlap. We say they are just resolved. The central maxima directly hit the first minima. So we say this one just nice, we can resolve them at the limit. But to our eyes, it seems like they are already merged, right? Yeah, but in this case, I think the diagram not very clear. In fact, you still can see them as two different images. They just nice see as two, okay? Yeah, but the condition is the central maxima of one image, different color, then you know what I'm saying. So this, what I mean is this, the red image, the central maxima of the red image coincide with the first minima of the blue image. This is the first minima blue image, right? Yeah, this is the closest possible for these two images so that they are just resolved. And so we come to this very powerful Rayleigh criterion. What is Rayleigh criterion? It said that two images are just resolved when what? When central maxima of one image coincide with first minima of another image. Okay, that's what they're trying to say. For example, there's this one. This is the first minima of blue, right? Coincide with central maxima of red. We say these are the two objects, like two pimples or two stars, you know. This is your lens, this is your retina. So this angle theta is the closest angle possible between them. This is what we call the limit of resolution. Limit of resolution. That means closest possible so that these two images are just resolved. And do you realize this theta is actually equivalent to this theta? Everybody? Do you realize that? So if we extend this backwards, this theta and this theta are the same. Can't you see? If this image land here, so this one will be like this already, right? See, the central maxima of the pink image coincide with the first minima of the black image. That's why we say they are just resolved. This theta and this theta are actually the same thing. And we have already learned about this theta just now, right? From the single slit, the formula is sine theta again, what? Lambda over b. Tangent theta again is what? Y over d. This triangle, we make it bigger now. We make it bigger. So you can see this triangle, right? This triangle, you can see, right? So this distance is let's call it x. X is the distance between two objects that are very close. This W is the distance between the lens to the object, okay? And this is theta. So what you can say tangent theta is actually equivalent to x over W. We can connect these three equations. We can connect this and this and this equation and do whatever they ask you to find. They definitely will find what is the distance between two objects. Then they ask you to find x. What is the distance between the object and the lens? They ask you to find w. You see? So that is the idea. And finally, what I want to tell you is, in exam, they love to use small angle approximation. They say, oh, theta is small, which is true, right? Very small, right? Then sine theta will be approximately theta. Sine theta is lambda over b, right? So they love to use this approximation for resolving power. Theta equal to lambda over b is sometimes used, but do not forget, the condition is the angle must be small. Okay, so add on here, resolving power, theta is proportionally lambda over b. Okay, and how to increase the resolving power? That means, how can I see something so close together and yet I can see them as two different distinct images? I must increase the resolving power, right? To increase the resolving power, theta must be very, very low. Okay, not very high. Low means what? Low means even though they're very close, we still can distinguish them. That's the meaning of high resolving power. So in this case, theta very low. That means what? Means lambda very low. B must be very high. What is the meaning of B very high? See, remember B is a slit opening here, the slit width. What if now, if the slit is very low, what will happen? I have two images here, let's say. They will spread a lot. They will spread a lot, right? One is black, let's say another one is pink. They overlap very easily because they have very large angle of diffraction. But if we decrease the B, make this B very, very close. What happens when you make this B very, very close? Sorry. We make this B very, very big now. Make this B very, very big. What will happen? Oh, do you think they have large angle of diffraction? No more, right? Because when remember when the slit width is big, they cannot diffract well. When they cannot diffract well, the black color will become what? The black color become this already, become less spread out, right? Then the pink color also become less spread out as well. Oh, so the pink color may be like this, become like this. So you see, they no longer overlap. That's why they already resolve, right? Yeah, that's what I meant. You must use big opening and small lambda. What is the smallest lambda in the world? Is electron. Yeah, in secondary school, you learn electron is a particle, but in JC, electron is also a wave. You will learn this in quantum physics. So that's why in this world, we have something called electron microscope. Electron microscope is something that we can see something very small, right? Electron microscope has very, very high resolving power. Okay, so I hope you have better understanding now about single slit, double slit, and diffraction grating. See this again and again and again until you can recall all this nitty-gritty part. I'll revise with you more in the future and do more exercise so that you gain mastery. See you guys.